Hello again. This is Lawrence from Silicon Valley High School. For this video, we'll talk about the common layout managers for the AWT package. So we have five of them. We have the flow layout, border layout, grid layout, card layout, and the grid bag layout. The flow layout is the default layout manager for both panels and applets. So whenever you use a panel and you started putting components inside the panel and you did not define what layout manager it's supposed to use, it will automatically use what we call the flow layout. As for window frame and dialog, the default layout manager is what we call the border layout. Border layout, when you use them, you need to specify a location. Of course, these are the default layout managers per container, which means you can also change them if you feel the need. Now, I've prepared some sample codes for us to look at. Okay, let's take a look at how a flow layout looks like. Now, in this example, I have a class called flow example and I've declared a frame and three buttons. Inside my constructor, I've instantiated the frame having a title bar of have a title bar named flow layout, and then I created three buttons. Button 1, 2, and 3 will have a label of OK, open, and close, and a user-defined method called launch frame, in where I will configure or set the properties of my frame. So what I did was, after instantiating all the objects and they're floating around in your memory, I can now assemble them. But before adding the buttons inside your frame, we need to set the layout manager first. Now, in line 17, when you say f.set layout, new flow layout, you are changing the layout manager of the frame from border layout, which is the default, to what we call a flow layout. And then after changing it to the flow layout manager, we added three buttons. After adding the three buttons, we've set the size and set the visibility to true. Okay, and then in our main method, we've launched the frame and called launch frame afterwards. So let's take a look at how this code, or how does flow layout looks like. Flow example, all right, Java flow example. So you have launched a frame. Now the frame is 100 by 100 pixel values. You'll notice that we've added three buttons inside the frame: button 1, button 2, and button 3. So where is the third button? It's actually right about here. Frames are resizable. Now, the reason why it's called flow layout, because it's free flowing. The default location of each component that you put inside your container is always top center. That's the default. Now, when you start resizing your container, you'll notice that the components inside your container are free flowing. That's why it's called flow layout. The components inside are free flowing. So when you resize them, chances are the components that you've placed inside your container will also move as you resize your container. Alright, so that's flow layout. It is the default layout for panels, but we're using a frame to show you an example. For border layout, here's another example for us. So I have a frame and I've created 5 buttons: BN, BS, BW, BE, and BC. These will specify the location. This one is for button north, button south, button west, east, and button center. Because whenever you use a border layout manager, you need to specify where to place a specific component inside your frame, inside your container. In your flow layout, when you add your components, you simply say f.add and then you add your component. In border layout, when you say f.add, you need to pass the component that you're adding and its location. Without the location, the default location will always be center. So assuming you've forgot to place the location, these parts here, the second argument, okay, all 5 buttons will be added in sequence and all of them will be placed in the center, one on top of the other. That's why it's very important that you put the location where you would like to put your component. So I have a frame, I have a button, I have constructed the frame and the button in our constructor. And in our launch frame method, you'll notice we do not have any set layout method. No set layout method was called because we are using the default layout manager for the border, for the frame, which is border layout. So when you start putting components inside your container, again, you need to specify the location. Our frame was set to 200 by 200 pixel values, and we've set the visibility to true. Let's take a look at this example. So Java C border example.java. Here we go. All right. So notice that all 5 buttons were added. B1 was placed in button north. B2 is in button south. B3 is on the west. B4 is on the east. And B5 is on the center. Knowing the location of each button, you can now control its resizability. Meaning, components on the north, center, and south can only be resized horizontally. Notice B1, B5, and B2, they are resized horizontally. B3 and B4 are not resized at all. But when you put components on the west and on the east, okay, as well as in the center, these components can be resized vertically. Vertical resize. Alright? So B5 is the only location where you can resize both horizontal and vertical. Alright? So much for border layout. Okay, what else? We also have what we call the grid layout. For grid layout, you need to specify the number of rows and columns that you would like to use. Here's an example for grid layout. Okay, so I have a frame, and let's say I have 6 buttons. Inside my constructor, I've instantiated my frame, which is the container, and my components. In this example, all 6 buttons, B1 all the way down to B6. Frames, by default, uses border layout, so I need to change the layout manager to grid layout. Now, the numbers that you see here, 3, 2, specifies the number of row and the number of columns that you'll have in your grid. So when you start adding your buttons inside your frame, B1 all the way down to B6, the sequence will be from left to right, top to bottom. So let's try to put a comment here. Left to right, top to bottom. That's how you add the buttons inside your frame. Alright? As for the size, in the previous example, we use set size method to specify or to hard code the actual size. 200, 200, that's in pixel values. But if you don't want to think about the size anymore, you would just like let the virtual machine set the size for you, you can also use f.pack. F.pack, the frame will be created and the size of the frame will depend on the number of components that you have inside. Meaning, the more components you have inside your frame, the larger your frame would be. But if you only have, let's say, a frame and just one button and you use f.pack, chances are you'll have a smaller frame. So in this example, we have 6 buttons and we use f.pack. So your frame will be large enough to accommodate all 6 buttons. And then we use f dot set visible to make sure that our frame will be seen when we run it. So let's try to run it. Java C grid example.java Java grid example. So here we go. So you have your frame and we're using grid layout. Notice when you added B1 to B6, it's from left to right. The sequence how it's been added is from left to right, top to bottom. Now, grid layout makes use of grid values, and when you start resizing your container, notice that all components inside your container will always be equally sized. So whenever you resize it, all components will be equally sized. Alright? So that's how a grid layout looks like. Also, we have the fourth one is called card layout. Card layout meaning each component will be treated as a flip of a card. So here's an example. I have used a swing component here. We'll talk about swing later. Okay, but just to show you how a card layout works. So I have 3 buttons, B1, B2, and B3. I have a container, alright, which makes use of JFrame. And I'll be using card layout. So in my container, I'll be using card layout, and that will be placed in the card variable. So when I say container.setLayout, pass the card layout object here. So my JFrame will now be using a card layout. Alright? Now when we try to add all buttons inside when we instantiated all our buttons and we added all buttons inside our container, okay, notice that when you add them, you will only see one component or one button at a time. And then whenever you click a card or whenever you click a button, you will see the next button. So the button that you will see first is alpha. Once you click it, it says here dot next, meaning you're supposed to see the next button, which is Bravo. When you click it again, you will see Charlie. All right. So let's take a look at the definition of card layout. So it says here, the card layout class manages the components in such a manner that only one component is visible at a time. It treats the component as a card. That is why it is known as card layout. So let's take a look at the runtime of this example. Java C card layout.java Java card layout. So you have a frame, and inside the frame you have a button called alpha. All right. Now this one is a button. Now when I click this, another card will be seen, which is called Bravo. You're seeing one card at a time. When I click it again, you'll see the next card, which is called Charlie. And then as you click, it will simply go through the rest of the buttons, and you're seeing one card at a time. That's why it's called card layout. You're viewing the component as if they are treated as cards. For grid bag layout, the Java grid bag layout class is used to align components vertically, horizontally, or along their baseline. The components may not be of same size, which means when you create a code that will make use of grid bag layout, it is intended for components that are not equally sized. So for irregular shaped components like this one, you can use what we call a grid bag layout. So much for layout managers. I hope you were able to understand the use of each one. In the next video, we will try to come up with our own calculator and create an application, a simple calculator, and I'm going to teach you how to decide which layout manager that you can use for specific scenario, for specific application. I hope you enjoyed this video. See you on the next one. Happy coding!